Hello, everybody. Welcome to my presentation of examples on the topic of separation of variables. I want you to watch this video in case you had a hard time understanding or just didn't really comprehend the step-by-step solution that I provided. So let's get into the first question. So the first question, we have a differential equation, which is dy over dx equals x squared over y squared. This is actually an ordinary differential equation that we can use the separation of variables method for. And so the reason we know that we can use the separation of variables method is because we actually identify that it is separable, since there is an x and y squared on one side, and this we can separate it into x's on one side and x's on the other side. So after we identify that it's separable, the second step is to actually separate those variables. So you can see that I multiplied y squared over and I multiplied dx over. So I was able to get y squared dy equals x squared dx. So now they're separable and we are able to integrate this problem, the third step in the separation of variables method. So after the integration, we get y cubed over 3 equals x cubed over 3 plus c. And don't forget the c, because that is a very important part as a constant of integration. So now that we are able to solve for 3, or now that we have a separable equation, we want to solve for y so we can get the particular solution. So for solving for y, we can actually multiply the equation by 3 to get rid of those denominators on the 3, or on the bottom. So we get y cubed equals x cubed plus 3c. Now 3c is a constant, but we can write regular c for that because a constant will continuously change, so it is the total sum of all constants. Now we actually have to complete, so we are at y cubed and we need to complete the solving for y. So now that we have y cubed, we can just root cube it to the other side. So we're left with y equals root cubed of x cubed plus c. Now this is the general solution, but most problems don't really just ask for a general solution, they ask for a particular solution. So let's say that they give us the points y of 1 equals 2. So since they gave us this initial condition, we can actually plug in 2 for y and 1 for x. So as you can see below, I did that. I did 2 equals 1 root of 1 cubed plus c. Now to solve for c, I actually had to root cube the root, and that means I had to do that for the other side, so I had to cube the 2. So now I get 8 equals 1 cubed plus c. And 8 plus 1 cubed is just 1, so it's 8 equals 1 plus c, and we get that c is 7. So now that we know that c is 7, we can plug that in back into the general solution, which is y. Oh, I forgot to write the y, but y should be there. It is y equals root cubed of x cubed plus 7, and that is our particular solution. I'm sorry for writing the y, or not writing the y, but it is okay. That is a more basic example, and for our second example, as I will show you in a second, we will get a little bit more in depth so you can understand. But that is the general steps and ways to solve for the general solution, and then adding the particular solution on top of it. Roll Tide, roll! Okay, so next up is equation number 2. It might be, sorry for it's a little bit messy, but we will work through this together very slowly. This is the same method as the first equation, just it's a little bit more meticulous in the way that we solve it. So I just want you to get a better understanding of just the regular basic steps. And so yeah, let's begin. So the first question we have, so basically we are finding this particular solution and the general solution for this problem right here, which is dy over dx equals xy squared plus 2y squared. And we can see that we have an initial condition of y of 0 is equal to 1. So let's not worry about that till later. But first, the first step we have to do is identify that this is a differential or ordinary differential equation. And it is because we can see that it is able to separate x and y on both sides by doing a little bit of algebra too. So as you can see in the step below, so what I did is I just multiplied dx over and I factored out the y squared from the problem. So I was ended with dy equals y squared x plus 2 dx. So now you can see that the y and the x are still not separated, but to separate them, we do divide y squared over. So our separable equation is dy over y squared equals x plus 2 dx. And we can now claim that this is separable and this is the correct form to integrate. So as you see the step below, I wrote y to the negative 2. That is the same thing as dy over y squared, or y to the negative dy. That is the same thing over dy of y squared. So now we can integrate these, and you can see in the step below, I actually integrated this problem. So it was y to the negative 1 over negative 1. There is another way to rewrite that, but we will wait for that in a second. And then on the other side, you can see I equaled it to x squared over 2 plus 2x. And then always don't forget the c, as that is a constant of integration, and we need that. So you can see in the step below where it says rewrite, I just flipped the signs. So I was able to write negative 1 over y, since it is the same thing as y to the negative 1 over negative 1. So then I just equaled it to the problem we got before. But you can see on the right side, I need to find a common denominator to be able to solve this problem. So I had x squared plus 2x plus c, but the 2x and plus c are over 1. So I multiplied the numerators by 2, which gave me, with what you can see on the bottom, negative 1 over y equals x squared plus 4x plus 2c. So after I got this, I noticed, or I purposely set it up this way because we can now flip it and do the reciprocal. And the reason we do the reciprocal, or the reciprocal of negative 1 over y is negative y. And the reason we do that is because it's a lot simpler to solve for y, which is our main problem, or main point. So, so after that, after you flip it, you get negative y equals 2 over x squared plus 4x plus 2c, instead of x squared plus 4x plus 2c being on the top. So now, all we have to do is multiply a negative 1 over, since we have negative y, and we just get y equals negative 2 over x squared plus 4x plus 2c. And that right there is the general solution. So, after we do that general solution, now we can go back to our initial condition, which is y of 0 equals 1. So, y of 0 equals 1 is, we can plug in 0 for x and y equals 1, which you see I do below, and I get 1 equals negative 2 over the 0 to the 2 plus 4 times 0 equals 2c. So as you can see that those zeros just go away because they don't matter, and we're left with 1 equals negative 2 plus 2c. Now, to get it to equal 1, we have to make c negative 1, as it would be negative 2 over negative 2, which is just the same thing as 1. And so we find that negative 1 is our particular solution. So, or that negative 1 is our constant of integration. So we come over and we just add that negative 1 to our general solution, as we get y equals negative 2 over x squared plus 4x minus 2 because it is plus 2c, and we just add that -1 to make it -2. So that is number 2 problem. It is the same concept, just a little more tedious. I hope you enjoyed. I hope you understood. So just to recap everything, we identified that it was differentiable. We then separated the variables. After we separated the variables, we were allowed to integrate. Then, as you can see, the 4th step is solving for y, which is just the meticulousness of it. After we solved for y, that actually gave us our general solution. And then step 6 was step 5 was applying any initial conditions that we had. And we had the initial condition, and we applied it, and we put the constant of integration back in, and we were able to get that particular solution. So I hope y'all enjoyed. I hope you can understand the idea of separation of variables now. Have a great day, and roll tide, roll.